Yeah, g'day guys. I got 3 machines here in my shop, and this one have got electrical problems. So let's see if we can fix them. Okay, so why don't I have good electrical troubleshooting chops? Let's rewind to the start of 1989 when I started my aircraft mechanics apprenticeship in the Royal New Zealand Air Force. Trades get split up a bit differently in each country and in each system. The Royal New Zealand Air Force split them into 8 separate trades. The smallest trades were like painters, the composite guys. They were previously called plainwrights, but as wooden structures disappeared, they transitioned to modern composites. I would guess that trade's probably grown a lot since then. Then there were the machinists that were really tool makers, welders. Now these guys could probably weld thin tinfoil to a bridge girder. There was safety and surface. They were specialized on textiles, pilot zoom bags, G-suits, parachutes, helmets, life rafts, that sort of thing. The armorers, strange bunch. They did both the mechanical and the electrical for things which go boom, plus the ejection seats. And that brings us to the most populous trades. Avionics, we called them tweets, was an amalgamation of electrics, electronics and instruments. So they also learned fine mechanical stuff. This was the hardest trade and they had the longest courses. And that brings us to the aircraft technician, which is the trade I did. After 3 months boot camp, we then did 3 months basic engineering, where had I known how blunt their files were, I would have brought my own files with me. We then did 8 months of full-time residential mix course. Avionics, they did 13, with both classroom and practical shop time, learning structures, hydraulics, aero, recips, gas turbines, helicopters, which of course are not really aircraft, so they got their own module, pneumatics, everything. After mix course, we got sent out for job rotation for 2 years. I did skin bay, overhauling flight controls, heavy maintenance on the Skyhawks, then some time on squadron doing like flight line and line maintenance, and then engine bay, before returning to the trade school for the 6-month technician's course. Once again, Avionics did like 11 or 12 months for their techs course. During the techs course, you were deeper into the same modules, plus you added things like high-speed aero. So after completing my training, I then did another like 18 months before I demobbed, working in the pilot training squadron, doing line maintenance and phase checks on the little puddle jumpers. Although they taught me decent sheet metal and mechanical inspection skills, because tweets were dime a dozen in our Air Force, all the electrical problems were assigned to them. So like if I found a burnt out landing light on a daily check, I'd raise a job card and then a tweet would come out and fix it. We used to joke that corrosion's an electrochemical process, so the avionics should be responsible for fixing it as well. When I started in commercial line maintenance at Lauderair, it turned out the trade split was quite a lot different. Sheet metal work was not in the skill set of most B1 licensed engine and aircraft mechanics. Sheeties was a separate trade, and it was mostly POMs who would be contracted in as needed. So whereas the New Zealand Air Force had nearly 1-to-1 tweets to blackhanders, Lauderair only had about 1 to 10. So there was typically only one avionics B2 engineer per shift, and they would be doing complex troubleshooting, wiring modifications and stuff, while the regular B1s covered all the simple line replaceable unit swaps, light bulb changes, continuity check, troubleshooting. That was all part of our scope. So what does this have to do with my machine's electrical problems? I didn't even know how to read a wiring or logic diagram until my first full type course on the Boeing 777. And this is what brings us up to today. I've since learned how to read wiring diagrams and how to wire up machines, but I still have pretty poor skills with respect to the sort of methods and the approach of how do you go about troubleshooting like an unknown electrical problem? Where do you start? What steps do you take? How do you isolate the fault? The problem with this Jones & Shipman surface grinder, which is new to me, now in my first video of this series, I found out that this contactor is stuck on, so as soon as I hit the start switch, the spindle starts. So I have to hold this off button to stop it. And also, according to the manual, the spindle motor is the stronger of the 2 motors, with the hydraulic motor being weaker. Now I'm suspecting that the motor connections are being switched over at some stage, because this one should be too weak for the main spindle motor, and this one too powerful for the hydraulics. Let's just disconnect this at the wall and maybe we can work out why that's sticking. I did notice there's a little window here which says off on this one, but doesn't on that one. I've still got a wee bit of space back to the wall here, both at the top and down here at the bottom. So I think I'll just move this back a bit and give myself a little more space in the garage. Right, didn't gain much, but that'll do for now. Right, I'll open this one too and see if I can spot the differences. Maybe just the nameplates were switched over, because these are identical, so if someone just screwed the nameplates back wrong, you'd get the wrong rating, but it's possible that they're actually connected to the right motors, just indicating something different. Since I don't know much about electrics, let's start with the mechanical. That was this one, and this feels like it's pretty normal. Doesn't feel like it's hanging up or anything. Whereas the other one does kind of want to hang up. Looks like it just needs a good clean out. Right, I'll try and blast the gunge out of each of them with a bit of brake cleaner. There's no stickiness in that one at all, but that was the problem one. Yeah, this one's still a bit sticky. Why don't I try removing it and cleaning it properly? I'll reinstall these, but in the opposite position. So this is the one that was here. Oh look, our number one fan Nico's popped by to have a look at my surface grinder.
Cool. Nice beat. New tool. New project.
Yeah,
Does it
look.
work?
What?
Does it work?
Well, not you as well. Right, I've plugged it in. Does it start the spindle again? Yes, it does. Right, well that wasn't it. Let me just unplug the machine. Okay, so the on button pushes on here, shorting those two poles behind it. So do they have continuity even with the button not pressed? Yes, they do. What about on the other one? No. So there's our problem. For some reason we've got continuity between here and here when we shouldn't do. So let's try it with this timer bypassed. Aha! That's somehow tied in with that timer. By the way, in the last video there were a few different opinions about what this timer circuit might be for. Some people thought it might be for some sort of automatic downfeed. Can't be, there's no automatic downfeed on this machine. Others thought it might be for like some sort of sparking out, and once it gets to the end of travel it would stop it. Because the table step over is purely mechanical, that's also not a function of this. Probably the most realistic I've heard is someone said you probably use it in the morning, run the hydraulics and the spindle and everything for half an hour and let the machine warm up so that it'll hold better tolerances. And the second idea was maybe it's used after shutdown to keep the spindle running for maybe a half hour to centrifuge any coolant out of the grinding wheel. If the grinding wheel is full of coolant and just stops, then all that coolant will flow to the bottom, the oil will stay in the stone and cause an imbalance. Okay, plugged back in, timer circuit bypassed. Aha! So there's nothing wrong with that contactor at all. Well, that's good. So the electrical grinder's problem wasn't really one. It was just lack of understanding of the wiring in the system. So let's move on to the mill. The initial fault occurred when I bumped the pendant down a bit harder. When I left you last week, I'd pulled apart my pendant from the milling machine because it was causing a short circuit. I'd concentrated on the e-stop, but an eagle-eyed viewer or two noticed the screw under here. The really sad thing is, when I took this off the milling machine, I actually heard a rattle, but I didn't bother to look for it. Some said it looks like it's this one, but no, I think that's screwed from the top because it's still nice and secure. I think it's one of the screws that came from under here. With that screw removed, I was back in business working on the pistons for my historic motorcycle engine replica, and I was just getting set up to cut the relief of the skirts of the piston when, well, I guess I'm not going to be machining those. I just had the machine trip the main breaker when the spindle started oscillating to do a tool change. Breaker went down, shut down, reset the breaker, restart the machine, but it looks like I've either blown the monitor or blown the computer or something, because the machine's coming up but the computer's not. So let's just quickly move the machine out. I'll open up the control cabinet and see what I can find. Okay, I think I can see it already. In addition to dropping the house circuit breaker, it also dropped this main breaker Q2. I'll reset that as well. Everything else looks like it's still on. I'll plug it in and see what happens. Oh. Uh-oh. Totally uncool. That is the end of a Mesa 7i84 card. At least the smoke looks pretty. Okay, so after that little disaster, I've pulled the board, and sure enough, that's gone over the Jordan. I'll put a request through on the LinuxCNC forum to the designer of these boards, Peter. Maybe he can give me some troubleshooting steps of what I'm looking for that would have caused this. Probably a short, I'm guessing. Look at this. I posted my request for help, and 11 minutes later, he came back to me. Peter, that's amazing customer service. Good on you, mate. To work out whether this card is completely bricked or not, Peter told me to remove both of the chips for the output switching, and then once those are off, power it up and see whether the brain still wants to talk to us. Before I start, I just wanted to see which output pin was actually blown. First up, I used the multimeter to try and work out which signal had been blown, and I found it was pin 20 on terminal block number 3, which corresponds to output number 3. So looking here, the output 3 attaches to the input stage motor of my gearbox control. So I've been told the best way of doing this is just to cut the legs. So I've chopped out the 2 ICs, gone through and just removed all of the remaining pieces of lead with the soldering iron. I've done continuity checks between the connector of terminal block 320 up through the connection into this MAHO relay board, up through to the relay coil which it controls. I've checked, I think they're called a flyback diode in comparison to others. All of it seems normal. I'm not seeing any unusual shorts through here. So the next step is to take this board, connect it up to its mothership, and then power the system on and see whether the board still communicates properly with its 7i77 control board. Switch that on. Okay, I've got an LED going on at the far side of that one Mesa card. The PC's not powering up. PC, of course, should come on automatically. It's powered off 110 volts between pins 151 and 150. That's not powered, is it? Now, because my original problem had been a short in a 24 volt circuit from that one screw in my pendant, I got kind of confused that a 3-phase breaker would drop, and it took me quite a lot of time searching through, asking questions on the forum, measuring stuff, trying things out, shutting things down, trying to isolate the problem, and eventually it took way longer than it should to realize that the problem seemed to be right back at the power supply, the power delivery from the wall. And the reason I'm suspecting this is because when I measured through before, it seemed like I dropped a phase. Then a bit later it came back, and the only thing I'd done in the meantime was plugging in and unplugging. The kind of sad thing is I had to walk upstairs, write a forum post about why I don't understand any of this, and only once I'd finished writing the post I realized, oh well, maybe it's this. I'm kind of slow at this stuff. Well, look at that. One pretty loose connection with partial melting maybe. Tommy Light on the LinuxCNC forum did question what sort of voltage spikes do I get on the 24 volt rail when the main contactors switch. Once I've put a new ferrule on this and re-terminated it, I will need to still measure that with the oscilloscope, but not today. I must say finding that does make me feel a bit better about buying another Mesa card to replace the one that I fried, because what I wouldn't want would be put a new card in this old system without understanding what was root cause, only to have the new one get fried as well. Right, so if I now turn it on, okay, that looks much more like it. I've now got power going to the PC. Now with only that one LED lit on this board, I think I've fried it, but I'll ask Peter, the designer, to confirm that. If it's not fried, one of my very generous Patreons, Julian, has offered to solder the new ICs in. In the meantime, I will buy a replacement, but if I can get this one going, it'll be really helpful because I need some extra outputs of 24 volts on my Shipman lathe. So if I had a spare card, I could use it there. Right, well that's now booting up, but without a functioning I/O card, I can't get into LinuxCNC. That just errors out. I'll order the new card, but it'll probably be a couple of weeks before I get the MAHO up and running again, and therefore before I can finish my pistons for my motorbike project. So I guess in the meantime I'll concentrate on getting my surface grinder functional. But as you can see, electrical troubleshooting is really not one of my strengths. I sort of hopefully get to the right solution in the end, but it takes me a fair bit of head scratching and mucking around, so it's not a very efficient process when I do it. I do really appreciate all of the engineering forums that I'm involved with. They're all full of very helpful people. Also, I appreciate my Patreons and other supporters who help me out with this sort of thing. Especially the electrical stuff doesn't come natural to me, but we'll get there in the end. Thanks for watching.